Hey, hello, welcome to my talk with the title, How We Finally Migrated an E-commerce Platform to GCP. I'm Paul Puschmann, I'm a squad architect at Rewe Digital, and I'm there at Rewe Digital since July 2014, and I'm taking care about the eCom infrastructure. eCom. So what is it? eCommerce-environment is providing customer-faced applications for Rewe. Rewe is a big food retail company in Germany. We are doing www.rewe.de, shop.rewe.de, mobile apps and some APIs, all in the context of the food delivery service and pickup service, as well as added services for the stationary markets we have. In a previous talk in 2018, where I described the migration from a monolith to a microservice architecture, I finished with a slide, our future is GCP, Google Cloud Platform. Well, let's see and find out what came out of this. So back in the times, we had virtual machines running on some dedicated hardware and bare metal machines, driving this microservice infrastructure. Everything is automated and configured with Ansible, and in general everything was under control, but we needed more flexibility for scaling and for different configuration setups. And back in 2018 or 2019 the plan was, wow, let's migrate to GCP, which meant let's migrate to GKE. So migrate our Docker-based environment to something based on Kubernetes, the Google Kubernetes environment. With the idea, make it even more scalable, use some different approaches, how to do things, and it looked very interesting and nice. So we kicked off with some migration team, infrastructure, VPN, everything was configured. The first tests were made, how to deploy, how to intercommunicate with the old environment, and then we very sadly ran into a wall. And the wall was the very high communication overhead and coordination overhead with our development teams, and especially the product owners, who had some efforts in moving the current way of deploying services to a Kubernetes style. And it was very difficult at this time, because we couldn't do an exact estimation how long would it take to transform all services, all of our teams to Kubernetes. And we wanted to keep the migration itself at this time as short as possible. So not spending too much time on an questionably reliable VPN tunnel, for example, and it was very uncertain how this could gain traction again. But we then found a different approach, and the approach is what we called lift and shift, although this is not the perfectly right term for this. The idea was to use just the exact same tooling as with the current eCom setup, so on this hosting provider, with some nice additions. So terraform everything at GCP, so everything should be in code. Use just simple GCE instances instead of Kubernetes. Configure the GCE instances with Ansible. Yes, all roles and playbooks were already in place. And then just migrate data centers. We had already had very interesting things in our stack already that supported this very nicely. For example, an external Cortex and Grafana setup. So it's a scalable Prometheus setup that is provided by us from a different team, and this is just outside of our infrastructure, so we can just ship data to this Cortex setup and just make use of it. We don't have to take care of this on our own, and this enabled us, for example, to just nicely compare metrics of the old environment and, for example, the new environment. Then we had an extensive setup of Consul. So Consul as a service discovery tool was very deep into our infrastructure, and I'll shortly introduce how and why we do it. This really helped us to finally do this migration. Then also some Postgres setup with PG Bouncer as a connection pooler. Central connection pooling also is enabled us to just configure database routings from one single place. Very nice. And last but not least, Nomad, Kafka, and our centralized container deployment scripts, where we could just easily, for the deployment scripts, make changes at one time that had an effect on all of our development teams in this ecom environment. So Consul, how does it work? How do we use it? So Consul is installed and as a server component on 5 nodes, and all other Consul agents that are distributed on the other virtual machines or instances act just as clients. And Consul is listening on the port 8500 and 8600 per default. The first one is doing HTTP requests for web UI and API requests, and the latter one is used for DNS queries. And we heavily rely on these DNS features of Consul because we use it just a lot. The subdomain .consul is delegated to this Consul servers. So underneath this subdomain is just the Consul namespace to separate it from everything else. As you can see in this graph or this picture, every instance where you install Consul, and given this this Consul is defining itself as healthy, is discoverable by its instance name plus node.consul.myinternaldomain.net. So you could also just address virtual machines or instances with just Consul usage. As an additional feature, and this is what we really do most of the times, we register services inside of Consul. For example, in this case, PG Bouncer, and for PG Bouncer just announces itself into Consul, and every client that just wants to get to know, okay, where can I find pgbouncer.service.consul, will just get as a return the IP address of this machine, and this is the very first thing to create a connection to this PG Bouncer, how to find it. And you also can do health checks and health checks on the components that you advertise as a service. And for example, in this case, we just do a simple TCP health check. Is this TCP port available or open? Check it every 10 seconds with a timeout of 1 second. And if this health check, for example, just fails, then immediately this instance or this service provided on this instance A will just drop from Consul and is not any longer discoverable. On our Docker hosts, we use Nomad as an orchestrator. So Nomad ensures our Docker containers are configured and started. And Nomad also registers healthy containers in Consul. And a container with the app name appc, for example, with the service name appc, would get created as a service appc in Consul. So if you do a lookup on appc.service.consul, you would just get the IP address of the machine where this container is running. And we have an interesting setup here together with Consul template and HAProxy. So Consul template is a small tool that just listens on Consul events, and if anything changes, it generates, in our case, a new HAProxy config. So if a container, any container, is started or stopped or getting healthy or unhealthy, this is just an event that Consul template will then acknowledge. Every time a new HAProxy configuration is written, and HAProxy of course is then also reloaded, and by this we ensure all HTTP requests fired against HAProxy are routed to an up and healthy container instance. In this case, for example, for this app C. And as you might guess, we're using host names to route these requests to the containers. And we had a similar setup before with Nginx and with traffic, but now we choose to go to HAProxy because of some nice features. Here's some example with our Docker hosts. Just to give you a short overview how this could like. Let's just assume the application app A in the lower left corner. This is running on some Docker host, the Docker host A, with some IP address. This wants to do an HTTP call to an application called app B. So of course, what does the application do? First, an DNS request is fired, in this case against Consul, and the result are two records, because the app B is living on the left server as well as on the right server. So there are two instances running, and that's the reason why we have two results in this NS lookup. So the app A will then just create a request, an HTTP request, and it could happen that this IP request, this HTTP request will just get routed to the same instance, like on Docker host A. So everything will go to through HAProxy, definitely, because we use a standard port 80 there. Or it also could happen that this request is, or the next request maybe, to this app B is just routed via the second Docker host. And here also, if a container is getting unhealthy, it will just drop out of the service discovery. So it will just nearly immediately, I guess it is immediately, drop out of the HAProxy config as well. So any configuration change we have in our environment is just very dynamic and very transparent, and we like this feature very much. So as an example, app C as a container is just request or queried as appc.service.consul.mydomain, as well as, for example, PG Bouncer is queried in the same way. So the PG Bouncer service is also queried via pgbouncer.service.consul.mydomain. And we tended in the past to use short names inside of the environment. So you could just use app C to address the app C, or PG Bouncer to address the PG Bouncer. And this also worked very fine for us. In terms of monitoring and observability metrics, we use Prometheus, as I already told. So Prometheus is running somewhere in the data center and writing its metrics to this remote Cortex setup. And how does Prometheus know where to get metrics from, or where to fetch metrics? Well, the containers, or at least Nomad is registering the container information into Consul. So every time a container is brought up via Nomad job, it also registers information in Consul. And by using tags, we can also direct Prometheus to fetch data from the containers. So the Nomad will just add to its service definition a tag, okay, Prometheus colon admin metrics. Prometheus will query Consul for information. So where can I discover some services where I can fetch metrics? Reads these tags and then knows, oh, there's an application app C running somewhere on a Docker host, and I can fetch metrics on the endpoint admin metrics, for example. So, and this also here it applies if a container is killed, unhealthy, or just disappears of other reason. Also Prometheus gets this information very quickly from Consul and just stops scraping for this endpoint because this is, for example, unhealthy. In the same way goes around. If just a new container is spawned up somewhere, Prometheus will just pick up this configuration and once this container is healthy, immediately start fetching metrics without any other static configuration in a central place. This information about which path to scrape is just inside of the Nomad job definition. And this is very cool. For example, this Filebit exporter living here on some instance somewhere in our infrastructure. This Filebit exporter is just running there to export metrics from Filebit to be scraped by Prometheus. And how do we announce that there is some Filebit exporter on a machine? We just register it as a service. So on this local machine is Consul running, and Consul just gets some additional YAML object with a service definition of Filebit exporter. And this Filebit exporter setting or service also has some health check inside and also contains tags. Tags with the information for Prometheus. Hey, please fetch my metrics. I'm here. Please go to my endpoint /metrics. I have wonderful metrics for you. And this is also very flexible and dynamic. So we also in this case, we don't have to keep a central registry where to fetch which metric. It is just dynamically fetched via this service discovery in Consul together with Prometheus. So coming now a bit further into our main topic, well, it's the migration. And for the migration, we had set up a second logical data center in Consul. And I mentioned before that inside of a data center, we can do lookups with something like service name.service.consul. And this is very, very fine, very cool. But unfortunately, this is only limited to one source data, so to one data center. So you can use this service subdomain to query everything inside of one data center, like for example, everything that is just in the blue data center. This is separated. If you do the same query in the green data center, so green data center will just give you only the results of what is running inside of this green data center. But we found a solution to this. And the solution to this is Consul's feature of prepared queries. So these prepared queries help us to do lookups across data center boundaries without some reconfiguration of services or other infrastructure. So this prepared query will search, do I find a service inside my data center, in my local data center? If not, it will just extend the query to the other data centers that are registered in your Consul and then return the matching results. And this is very cool because there's also a different feature in Consul where we could just query distinct data centers. So like in the above mentioned URLs like service name.service.datacenter2.console. Yes, you can do this. It also works very fine. But in our case, we didn't want to do it because we didn't want to touch the configuration of our services now, of our infrastructure in this behalf. So this would also mean that we, point the configuration directly to the different data center, and this was just not a good idea for our migration. So how to move from this service.console to query.console? Well, I explained already, using short names was a really cool idea because we then could only just do some changes to the resolve.conf on our machines, so on the search domain, and this was settled. So every request doing a short name would then just use this wonderful prepared query. And yeah, there were some cases in our infrastructure where we had the use of FQDNs, so this whole long domain name I already explained to you. Yes, we had to change these, and this was not very problematic. We could not really do it with an easy search and replace. There was some more effort, but it was doable, and it was just completely unblocking us from the upcoming migration. So, and with the prepared queries in place, we could just move around applications and other services between data centers and still have a very dynamic and intact communication between them. Lookups were just working fine, and it didn't matter where the application was located, if it was in the data center on the old hosting provider or it was on the Google provider. And by this, with this tool, we also managed just easily to migrate around our databases, for example. So on the source data center on the left side, you can see two applications. They are running app A and app B, and they are configured to use databases on the URL pgbouncer. So what do? Yeah, they ask for pgbouncer, get as a return value the local pgbouncer instance, which then forwards the request to the PostgreSQL primary server. And if, for example, app C was just already migrated to the Google data center or to the different data center, there was also already some pgbouncer instance running. The app C would also just connect against the pgbouncer as a short name, would get a result, well, it's a local pgbouncer, so in the Google data center, and only the pgbouncer knows, my primary PostgreSQL instance, this is running on the old data center, and routes the requests to the correct primary server. And the replication of the movement of databases was just somewhere behind the scenes. So it was just somewhere hidden between pgbouncer. The apps still connected just to their local pgbouncer instance, and everything else was just abstracted behind, and the applications didn't have to take care about it. And in general, also this complete migration of our Nomad jobs, so our Docker containers, from the old data center to the new data center was just very quickly done with some scripting on the Nomad API. So we could just move our Nomad jobs from one data center to the other data center with the exact configuration, with the exact URLs in the configuration, because we ensured with Consul that everything was just discoverable and just working fine. For the topic of Kafka, what we use for our event sourcing inside of our e-commerce environment, this is not directly Consul related, but the migration is maybe a bit interesting at all. So for the Kafka cluster, we didn't set up a completely new and fresh Kafka cluster at the Google data center. But here we choose just to extend the Kafka cluster with new brokers, so that we had one big cluster spanning over both data centers. And when you just add new brokers to your Kafka cluster, what does happen? Well, nothing. If you don't do any action on your topics, like creating topics, anything else will just continue working, but you won't have any data on your freshly introduced Kafka brokers in the new data center, because Kafka wants you to move the data on your own. So you have to do it with some script or some command. It is not behaving like some Elasticsearch where you just add an instance and shards are moved around to optimize the distribution of shards. It's completely different. But this was also very fine for us. So we could just provision new Kafka brokers at Google and then decide on our own when to move over or reallocate the partitions and all the topics from the old data center to the new data center. And since we knew what topics were on the one hand important, so under very heavy usage by clients, and you knew of course the size of our Kafka topics, we could make up a plan which topics to move first and which, for example, the very big ones, move them later. And after the finished reallocation, that looks then like this, we could just safely shut down the Kafka brokers and the old environment and just have everything migrated to the Google data center, for example. Coming now to the migrations. So how did our migrations actually work? Well, exactly as I already explained for the various infrastructure components. So Nomad containers, just move them back and forth. Databases, we did the same. So we migrated stuff and didn't tell anybody for our test environment because there was no high risk on the test environment. And we wanted and had to play around with it and learn things. How does it behave? And it was very cool to see that all of our assumptions were fulfilled. So it was very cool to see that things just work. We also did take a look into the metrics and everything. How is it running? How about latencies between the data centers and the VPN tunnels? How does it work? And it turned out, yeah, it was pretty fine. So there wasn't a big latency at all. So test environment, yeah, was very nice. And we did it over a longer time frame. So it was not just done in 2 hours or a day or whatever. For the pre and for the prod migration, we decided to do it differently. So we had the test environment to learn. And for the pre and prod environments, we wanted to take it literally. So pre-environment is our pre-production environment. And to ensure that we have no configuration drift, we had set up the pre-hardware and the prod hardware, so the virtual hardware, of course, at the same time to just do it exactly in the same way, in the exact order, not to fall into some pitfalls. And the migration of our applications, databases, and whatever in the pre-environment, we did it in a manner as we wanted to do it also in the prod environment. So we wanted to do it all, not at once, but all in one go. So we spent just one day to follow through our plan, how to migrate and when to migrate what. And we just did it without any downtime for our pre-prod environment, because all the technology we used there was just made for this. All the service discovery is just exactly made for this. So if you do a test environment and do a pre-environment, then you sometime have to do prod as well. And Well, what was stopping us? So we had very good tests. We had double-checked everything. The infrastructure was, besides of some sizing of GCE instances, for example, completely identical. And yeah, it turned out with all this information, we could just get some time slot and some date where to do the migration. And then came the day of our prod migration. So what did we do? Yeah, we checked everything, stopped the external traffic, failover to then, according to our runbook or our plan, failover the Postgres machines, created new replica at Google, started to migrate the Nomad-jobs, so the Docker containers, from A to B, so from the old hosting provider to the Google provider or Google data center, migrated our Solr, Redis, Elasticsearch instances over to Google, reconfigured the external DNS, and started the relocation of our Kafka topics in 2 batches. So as I explained before, we knew what to do first. So we did it, like in Pareto split. So all smaller topics first that were pretty interesting, and the bigger topics just do them at the very last, because we can just wait for it. And after most of the Kafka topics, for example, were done, we did some testing. So testing without customers. Is everything possible? Can we do a checkout? Can we whatever? Functional testing, taking a look at the metrics, taking a look at the logs, and then switched on the external traffic again. Happily welcome, dear customers, you can shop again. And we were done after 6 hours and 25 minutes. To be honest, Kafka took just 50 hours and 50 minutes to complete the complete reassignment of topics. But the main part of this whole migration was just done inside of 6 hours and 25 minutes. And the wonderful part of this is that we just did it without any external interaction. So only the platform team just did this migration, and we just moved everything to 119 new GCE instances, 200 microservices were moved, 138 databases migrated, and shipped around 5 terabytes of production data. So this was very, very cool to achieve this in this short time period. And this was the biggest single application migration inside Rewe ever. And this was just done in 6 hours. So when I call it application, well, it's this eCom product, this eCom environment. You could also call it an application if you like, for externals. So just completed this one small platform team, just migrated a complete prod environment, just single-handedly without any issues from a hosting provider to Google. Yes, we switched off external traffic, but only to maximize the data consistency of our data. We didn't want to deal with any split brain situations at all. We wanted to be 100% sure on this, and this was definitely something that we could take. And now we have everything in code. So every firewall rule, every instance configuration, whatnot, is everywhere stored in Terraform, and it is really nice to see this. So all this was heavily powered by Hashicorp Consul. So Consul was just the key thing in this migration with this dynamic setup and dynamic configuration. This really enabled us to migrate this environment and to do this stunt. And yeah, a stunt exactly like this. It only took a bit longer, like the stable clause, it was 6 hours, but hey, it was really comparable, and we are really proud to have done it this way without any further external interaction. I really love this, and thank you very much to this platform team who achieved this great task. Thank you very much. And now, please, I'm open for your questions. Tell me, what do you think of this? Do you already use Consul? Would you like to use Consul? Need any information? Just ask me. I'm here for you in the chat. Thank you and bye-bye.